Hello everyone, welcome to Reactify Labs. Today we will discuss the problem longest consecutive sequence. This problem has been asked in several companies' interviews, including Google. So yeah, let's see what this problem says and how to solve this question. Okay. So it says you are provided a number array, like an array of integers called nums. You have to tell what is the length of the longest consecutive sequence. Here, how do you define a consecutive sequence? So it's like this. So let's say you have this input. So what you do is you first sort it. Let's say 1, 2, 3, 4, then 100, then 200. So now you have to find what is the length of the longest consecutive sequence, like consecutive as in 1, 2 consecutive, 2, 3 consecutive, 3, 4 consecutive, right? So this length is 4. If you start with 100, there is nothing consecutive from here. It's just 100, right? There is no 101 to make it like 2. So this is 1, this is 1. So the answer for this is 4 because 4 is the longest, right? For this again, if you sort it, it will be 0, 0, 1, 2, 3, 4, 5, 6, 7, 8. Okay. Now if you see 0, 1, 2, 3, 4, 5, 6, 7, 8. This is the longest consecutive sequence. So the answer for this is 9. Okay. Let's say if there was something else 1, 4, 5, 9, 12, 11, 13, 10. Then for this, the answer would be, again, we will sort it 1, 4, 5, 9, 10, 11, 12, 13. So if you see 1, after 1 there is no 2. So for this the length is 1. 4, 5 there is 2. So sorry, for this the length is 1. For this the length is 2. And for this the length is 9, 10, 11, 12, 13. Length is 5. Okay. So for this the answer is 5. Okay. So this is what we have to do. But there is a catch. The catch says, the Leetcode problem statement itself says that you must write an algorithm which runs in O(n) time. Okay. So if you go and sort it, it will take n log n time. The best sorting algorithm takes n log n time, right? Which would be merge sort. Okay. I did not say quick sort because for this the worst case time complexity is n square. In merge sort, every time it's n log n. Okay. So we cannot do sorting. Okay. Now let's see how we can solve it. Okay. So the way we are going to solve it is like this. See, let's say you find 100. Okay. You start iterating over this number, right? So you first find 100. Okay. Now if you start searching from 100, like, okay, you got the 100. Now you start checking in some other database or some other array. Is there something? Is there 101 there? Okay. If 101 is present, then you will check if 102 is there, and you will stop until you find everything, right? So this is what you can try. So for 100, if you see for 100, we are checking 101 exists. No, right? So for this, the answer is 1. Now you encounter 4. Okay. So for 4, you will check, does 5 exist? It says no. Then again for 4, the answer is 1. Now for 200, you will check if 201 exists. Again, no. So the answer is 1. Now you will check 1. Does 2 exist? Yes, 2 exists. I mean, there is some other data structure where we are checking. Yes, 2 exists. So in this case, you will start checking, okay, does 3 exist? Like, does 2 exist? Yes. Then you will check, does 3 exist? Yes. Does 4 exist? Yes. Then does 5 exist? No. So it means for this, the answer is 4. Okay. So that's why the answer is 4. Next, again, for this kind of database, if you see, or the input, it's 0. Does 1 exist? Yes. Does 2 exist? Yes. Does 3 exist? Yes. So what is that data structure which can give us the presence of this 0, 1 to any element which is present in this array in a constant time? Constant time. Which data structure can do this? A data structure which can do that is unordered map and unordered set. In C++, in Java, it is hash map and hash set. If you don't know why we cannot use map or set and in Java it's tree map and tree set. Tree map, tree set. It's because searching for an element in this map or set or tree map or tree set, it takes log n time. Okay, so if we have to search n elements, it will be n log n time, which is similar to sorting, right? We do not want that. We do not want to do that. Okay, actually along with sorting, when you try to insert it also, for insertion also, one element insertion takes log n time, so total it will be n log n. So n log n during insertion and n log n during querying. So entirely it will take n log n time. That's why we cannot use tree map or a tree set, or in C++ map or set. Okay, so we will use unordered map. We have options like unordered map and unordered set. Okay, so which one will be more efficient for us? Actually both, but the thing is, unordered map you have to store key value pair. Okay, so what will you store? You will store like key, and against the value you only have to store if it exists or not. Like it exists, you have to write some kind of identifier, either true or 1 or any XYZ, anything, just to, like, it has no value basically. That's what I'm trying to say. There is no significance of storing the value here. So we will go with unordered set. Okay, and in unordered set, what we will do? We will just store. Let's say this is our unordered set. This is our unordered set. So in unordered set, we will just store that, okay, 100 is there in the set, 4 is there in the set, 200 is there in the set, 1 is there in the set. Because it's not an ordered set or normal set or a tree set, it will not be stored in sorted order. It will just be stored anywhere in the memory. Okay, so we will just do this. We'll store. Now what will we do? We will now iterate over this nums array. Okay, so if we iterate, like for I equal to 0, I less than nums dot size I plus plus. Okay, we keep iterating, and what will we do? We will check. Okay, so what check did we do? If you remember, when we checked 100, when we got 100, we checked if 101 existed or not, right? So let's say if the number is j, okay, let's say j is nums I. Okay, if the j is like int j is nums I, now we will check while next one exists. So while s dot find j is not equal to s dot end. Okay, so we start with this, like we have j, we know that 100 exists, but we still check, like, does 100 exist? Yes, 100 exists. So what will we do? We will do j plus plus. Okay, and does 101 exist? Now j is now 101. We will check, does 101 exist? It will say, okay, no, it does not exist. Then what happens? 101 does not exist. Then the answer will be maximum of answer comma j minus nums of I. Nums of I. Why? Because now 101 minus 100, which will be 1, right? So this is our value when the number starts with 100. Okay, but there is a catch here. What is the catch? Let's see. So if you see, now if we check, does 4 exist? Okay, so if we check, does 4 exist? So again, this j will be now 4, right? So j is 4. So we are checking, does 4 exist? Yes. So now we check for 5. Then 5 does not exist. So answer will still be 1, right? Next, let's see 1 or 200. So for 200, now j is 200. Okay, we will check now 201, right? Does 201 exist? 201 does not exist. So the answer is still 1, right? Next, we go to 1. Okay, when 1 is there, we check, yes, 1 exists. Okay, so j plus plus. J is now 2. So it means we are searching for 2 now, right? So when we search for 2, does 2 exist in this set? Yes, 2 exists in this set. So s dot find 2 will again not equal to s dot end. Okay, so 2 exists. Yes. So j will be now 3. And we will check, does 3 exist? Yes, 3 is also existing in this set. Now what will we do? Again, j will be moved forward. So j will be 4. Now we will check, does 4 exist in s dot find 4? Yes, 4 also exists. Now what will we do? We will make it 5, right? We will check again in the set, does 5 exist? Okay, so it will say no, 5 does not exist. So we cannot get 5. So this answer will be maximum of 5 minus num psi was 1. Okay, so answer is 4. Okay, so our answer right now is 4. Correct? Remember this. Now what happens is, we don't know, right? We don't know the answer that if 4 is the maximum. We don't know what elements lie ahead. So we will again keep iterating. This for loop will continue. This for loop will go to 3. So for 3, we will again check, does 3 exist? Yes. So now j will become 4. We will now check, does 4 exist? Yes. So j will now become 5. We will now check, does 5 exist? So 5 does not exist. So for this, the answer is 2, right? It means, now again, if we start from 2, it will be like for 2, then 3 check, then 4 check, then 5 does not exist, means 5 minus 2, the answer is 3. So still it will not be more than this 4, right? So as you see, the other checks that we did after we did the check for 1, the other checks that we did for 2 and 3, these were unnecessary. This is what we conclude after searching, right? After iterating, we found out that this check was unnecessary. Before that, we didn't know this. So what can we do to handle these kinds of unnecessary checks? Here it was like 4 elements, then that's fine. But let's say if tomorrow we get something like, as you know, the num's length is the size of this array can be maximum 10 to the power 5. What if the first element that was there was 1? Okay. And next is 2, 3, 4, something until 10 to the power 5. So remaining these 99999, these 99,999 checks will all be unnecessary, right? So we need a way to avoid that. How can we avoid that? So if we add some condition which can tell us that, okay, if a check for something smaller than current number has been done, we do not need to do it, right? So let's say if the number is this, and if we already know the check for 1 has been done, okay, if let's say for this, if you see now 0, if we start from 0, it will be like, okay, 0 check, now 1 exists, 2 exists, 3 exists, up to 9 exists, 8 exists, right? Then we already get our answer here. So if we start from 3, we will reach till 8, but the answer will be 6 only, right? We will never get any better answer. So if there is a way to check if a number which is smaller than current number has already existed or has been searched for, or it exists in the set, then we do not need to continue. Or let's say it's like this. If this 0 was not present here, if the input was like this, 3 7 2 5 8 4 6 0 1, okay, in this case, if you see, if we calculate from 3, we know we'll get answer 6, right? If we calculate from 7, we will get answer 2. If we calculate from 2, we will get answer as 7, right? If we calculate from 5, we will get answer as 4. If we calculate from 8, we will get answer as 1. If we calculate from 4, we will get answer as 5. If from 6, we get answer as 3. If from 0, we get answer as 9, right? We know that we will get answer from 0. Still, these checks were unnecessary, right? Even though the 0 was not present at the front, at the first place, still those checks were unnecessary. So is there a way to make sure that we do not even check those things? Yes, there is a way. So if we add a condition here, like if s dot find nums i minus 1, okay, if this is equal to s dot end, then only we'll do this. What does this mean? What does this do? What this does is, it will see, okay, if you see here, forget this 0, if you see this, so when we encounter 3, it will check in the set, okay, let's say in the set, again we have the same numbers, 3 7 2 5 8 4 6 0 1, okay. Here it will check, okay, does 3 exist? It will say yes, 3 exists, but does a number less than 3 exist? Does 2 exist? It will say yes, 2 will exist, means 2 exists, so it means 2 will give me a better answer, okay. So we don't need to check for 3. When 7 comes, we will check if 6 exists. Yes, 6 exists, so 6 may give us better answer than 7, so No, we don't need to check for 7 also. 2, when 2 comes, we will check does 1 exist, like this if condition, it will check does 1 exist. Yes, then 1 will give us a better answer, so we don't need to check for 1 also. Now when this comes, again iteratively, when 1 comes, then again we will check this number will check does 0 exist. Yes, 0 exists, it means again we don't need to check for 1. Okay, then when 0 exists, it will check for -1. Okay, and we see that there is no -1 here. So this if condition will check if -1 exists. Yes, -1 does not exist. Okay, like -1 does not exist. It means 0 will give us our answer. 0 will give us some answer. Yes, but it is possible that later something else also comes, right? So this is what we do. Okay, we will keep checking for if one lower number exists than this or not. Okay, you might say, okay, later, let's say tomorrow something like 100 and 100, 101, 102. If we extend this one only till 150 exists, then what? Yes, then still for this subsequence, this 0 will be a lot, right? But again, for this one, if we check, we will check for 100, we will check, does 99 exist? No, 99 does not exist. It means we will start checking from 100, right? But when again 101 comes, we will check, does 100 exist? We see, yes, 100 does exist. So in that case, 100 will give us our answer. So if 100 exists, then we do not need to check for 101. If 100 exists, we do not need to check for if 101 exists, we do not need to check for 102. Let's say similarly, if 105 exists, we do not need to check for 106, right? So just one number before that current number will tell us if we need to check for that number or not. If that number is present, we do not need to check. If that number is not present, then we will need to check. Okay. So I hope this clears, this gives you a good idea and why this if condition is used. I hope this is clear now. Let me reiterate it again. If we have a list of numbers like A, B, C, D, E, then if a number less than C, okay, actually this is complicated. If we have number, let's say 1, 4, 5, 6, 2, 3. So if for 4, actually for 1, we will check does 0 exist. If 0 exists, we do not need to check for 1. But since here 0 does not exist, it means 1 might give us our best answer. 1 might give us our best answer. But now we check 4. Does 3 exist? If 4 is there, so we'll check one number less than 4, right? Does 3 exist? Yes, we do not need to check for 4. When we go to 5, we will check does 4 exist? Yes, we do not need to check for 5. For 6, does 5 exist? Yes. For 2, does 1 exist? Yes. For 3, does 2 exist? Yes. So it was only for 1 that a number smaller than 1 did not exist. 0 did not exist. So we will check only from 1, rest other will be taken care of. Okay. Now let's say there was another number here, 8. Here we will check 8. Does 7 exist? No, 7 does not exist. But then we will check 8. Since 7 does not exist, we will check for 8. Why? Because we don't know. There might be a sequence which starts at 8 and ends at 1000, right? So we'll check. But after checking, we find out that no, there is only 1. That's just 8. So we don't need to go forward. Here, the answer that we got was 1. So the answer is still 6, which started from 1. That's what we need to do. Just check for the presence of a number smaller than the current number which we encounter while iterating. If that number is present, then we don't need to check for the current number sequence. If that number is not present, then we will go start checking for the sequence. Okay. So yeah, I will add the solution code in the description of this video. I hope this gives you a good understanding of how to solve this question. Please try writing the code. Actually, this is the complete code, but yeah, still I'll paste the working code in the description. Okay. So please try it yourself first before looking at the code, before looking at the solution code. Okay. So yeah, that's all there was in this video. Thank you for watching. Please remember to like, share and subscribe. I will see you in the next one.